Okay, full battery. All right. So theorem number one, and again, I sent it through the scanner, so it's not a great picture, and I apologize for that. Theorem number one says, in a circle, do you guys care if I sit down? I haven't sat down okay, I'm sorry. That's good. You can leave all your stuff there. In a circle or congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. Well, we already learned that congruent chords make congruent arcs. We've already had that theorem. So what does this mean? This just means, I need to make it bigger so I can write on it. This just means if we were to label this A, B, C, and D. So call this polygon ABDC. I don't know why I labeled it that way, but I did. So if AB is congruent to CD, and these are segments, then what does that mean? That means that arc AB, put a curve over the top of it, is congruent to arc CD, put a curve over the top of it. Okay. And we're going to practice this. Are we okay with that? Okay, I'm going to slide it up a little bit. So the next theorem says in a circle, if a diameter or a radius, because remember, a diameter comes from two radii. So this is true even if you only see a radius. If a diameter or a radius is perpendicular to the chord, then it bisects the chord and the arc. So I'm going to call this circle C, and I'm going to label this A, B, and then I'm going to put a D right here. So my radius, so let's just label the pieces. My radius is segment CD. Does everybody see that? I'm going to call this point where they intersect E. Are you okay? Do you see where that right angle is made? So my chord is segment AB. And I notice that AB is perpendicular to CD. At point E. That's where they intersect. So what does that mean? That's what I can see. So because the radius and the chord are perpendicular, and they're perpendicular because it is a radius. What does that mean? Well, that means that the chord is bisected. So AE is congruent to BE. That's the definition of bisector, right? Bisect means it cuts it into congruent pieces. But also, arc BD is congruent to arc AD. BD is congruent to AD. We're on journal 6.5, number 1. So I'm going to mark this so you can remember it. I'm going to use a different color and mark it. So these two are congruent, and the arcs are congruent because they're bisected. Remember what bisect means. Bisect means it cuts it into two congruent pieces. Okay? I'll even say that. I'll say that CD bisects AB, the segment, the chord, and AB, the segment. Okay. And then we have one more theorem, and we're going to practice these. In a circle or congruent circles, two chords are congruent if and only if they're equidistant from the center. So they're congruent if and only if they're equidistant from the center. So let's talk about the distance. I need to do some labeling here. So I'm going to call this circle P. Circle, why are you not writing? Circle P. And I'm going to call this point Q and this point R. So they have to be equidistant for this to be true. So equidistant means, remember, distance is measured in perpendiculars. So if they're equidistant, that means that PQ is congruent to PR, the segment. So I'm going to write above it equidistant. I'm not going to write above it because I can't fit it in there. I'll write below it. That's what equidistant means. Those perpendiculars are the same distance. So if those chords, what are the names of our chords? Well, let's call this chord ST, and let's call this chord down here chord UV. So we can say that ST is congruent to UV because QP is congruent to QR. So ST is congruent to UV. That's what it means. So if this happens, then this is true.
What does it say that's
Then. It says then. THEN. Sorry. Can I turn the page? I gave you printed copies of these. They were laying on your desk. That's okay. All right. So again, when I scan these, it cuts some of it off. So this says if AB equals 5x and CD equals 3x plus 6, we have to find the length of AB and CD. Okay. So let's see. This is 5x and this is 3x plus 6. Well, what do we know? What do we know about those chords? Are they marked as parallel? What do we know about the arcs? What can we say about arc AB and arc BC? Yeah, arc AB is 127 degrees and arc CD is 127 degrees. That means that arc AB is congruent to arc CD. And if arc AB is congruent to arc CD, I'm going to put those as congruent. If those are congruent to each other, then what do we know about if the arcs are congruent? Then the chords are also congruent. That was our first theorem. So how am I going to solve this? How am I going to figure out the length of those two segments? Well, I'm just going to set 5x equal to 3x plus 6. And I'm going to solve for x and then just plug it back in, right? Yay or nay? So subtract 3x from both sides. So 2x equals 6. Divide both sides by 2, which means that x equals 3. Well, if x equals 3, then chord AB has a measure of what? If x equals 3, then chord AB has a measure of 15 units. If x equals 3, then chord CD has a measure of 3 times 3 is 9 plus 6 is also, yeah, and it better be because they're supposed to be congruent since they cut congruent arcs. Do we feel okay with that? We know how to recognize that? So congruent chords cut congruent arcs, and congruent arcs cut congruent chords. Like that just makes sense, right? I'm going to go across to number 2. Number 2 just says find the value of x. Number 2 says find the value of x. Number 2, find the value of x. So we learned something about theorem 2 or theorem 1. What do we know about congruent arcs? Congruent arcs do what? Who just said that? Congruent arcs make congruent chords. Do we have congruent arcs? Yeah? Where? Yeah, do you guys see these two arcs are congruent? This arc right here is congruent to this arc right here. Do we see that? Okay. So because these two arcs are congruent, meaning they have the same measure, what can we say about the chords that created them? They're congruent, meaning that 12x minus 2 has to equal 34. You with me, Max? Looks like you're sleeping. Looks like you haven't twitched at all. Michael, what are you watching? Okay. How'd you do? What job do you want? Okay. Cool. Next time my nephew is home, he's an MSG. He goes all over the country as a embassy security guard. I'll have him come and talk to you. Okay, what do we do? Add 2. And then what?
And then you divide 36 by 12.
Yeah, divide both sides by 12. And we find out that x is what?
30.
So
And when you put 3 into 12 and then subtract 2, it's 34.
do we get 34? And we should, right? Because they better equal the same or we've made a mistake. How do we feel about that? Good. Okay. Given that chord BC is 15 centimeters from the center of the circle. So this chord is 15 centimeters away from the center. That's the distance. It's talking about this right here. That's what it's talking about. That is the 15 centimeters from the center of the circle A, which has a radius of 25. Where is the 25 radius going to be? What segment represents my radius? AB is my radius. We have to find chord BC and chord DE. Well, let's start with finding this measure right here. How are we going to find BD? What kind of a triangle is that? What's that fabulous theorem you learned from Captain P? What?
A squared plus b squared equals c squared.
Yeah, what's it called? Go ahead, Reese.
Wait, I was going to just point something out.
Oh, point it out.
If the radius is 25 and we're trying to find DE, then it's 10. DE is 10 because we already know 15.
It is. Did you guys hear that? Reese said, well, if the radius is 25 and segment AD is 15, 15 plus what is 25? So we already know that DE is 10. You're 100% correct. But we still got to find BD, and we got to use Pythagorean theorem. So what side is C squared? What side represents C? the 25, the hypotenuse. A and B don't matter, so I'm going to call it x squared plus 15 squared. So let's see, x squared plus 15 squared is 225 equals 25 squared is 625. When I subtract 225 from both sides, I believe I get 400, right? So x squared equals 400, and the square root of 400 is 20. So this measure right here is 20 centimeters. But it's not asking me for the measure of BD. It's asking me for the measure of BC. How do you know that?
Because the radius or diameter splits the chord in half.
Yeah, the radius or the diameter is a bisector, right? So if this segment measures 20, then this segment also measures 20. So let's write that down. Go away. So BC equals 40 centimeters. And Reese told us that DE equals 10 centimeters just by doing some subtraction. Perfect. 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 Do we feel okay with that? Okay. We ready for the next one? So we have to find the measure of AD, CD, and the measure of arc AB. All right. So let's just talk about what kind of angle is this? What kind of angle is this? What is the name of that angle? It starts at the center. The vertex is at the center of the circle. Yeah. So let's write that down. Angle ACE is a central angle. So what does that mean about arc AE? So arc AE is equal to 60 degrees. Because remember that central angles and the arc that they intercept are the same. Okay. What do you know about segment CE? What is it? It's a radius, and it's marked as being perpendicular, right? So we know that segment CE is a radius that's perpendicular to the chord AB. Hang on a second. So we know that CE bisects segment AB and, sorry, I wrote the arc first, and arc AB. So it bisects both the arc and the segment. And I have to name that arc actually AEB. Do you guys see that there's an E in the middle of that? Nothing on the other side. So this arc has to be actually called arc AEB because I'm going this way. Arc AEB. Well, if arc AE is 60 degrees, that means that arc EB is what? 60 degrees. So the measure of arc AEB is 120. How are we going to figure out AD and CD? The radius is 6, but that doesn't really help me with a whole lot. Huh? Yeah, but we're not finding CE. We can use that, but this is a special right triangle. This is a special right triangle. It is a 30, 60, 90. So remember the small side is x. The hypotenuse or the longest side is 2x. And this side is x times the square root of 3. So if we know that the hypotenuse is 6, then that means the short leg is 3 because 2 times something equals 6. And that means that the long leg is 3 times the square root of 3. Did you guys brain dump all your special right triangle stuff? Yeah? Okay. So we'll make sure that we review that. So let's see. Segment AD equals the long leg, which is 3 root 3. And segment CD is my short leg, which is 3. It's a 30, 60, 90 special right triangle. Do you guys remember the other special right triangle? Yeah, a 45, 45, 90. Do you care if I write that down really fast and just tell you the specifics about it? So what do we know about a 45, 45, 90? Well, we know that it's isosceles. And if this measure is x, then this measure is x. And the hypotenuse is x times the square root of 2. That's for a 45, 45, 90 right triangle. Do you guys maybe remember doing that? Okay, that's math 2 stuff. Can we go to number 5? Okay. Number 5. In circle A, FG, it's not even labeled right. What should this circle be called? Yeah, this should be called circle G. I actually have to white that out and fix that. Oh, no, I got to fix this. We are going to turn that into a G. Why should it be called circle G? Yeah, that's the center of the circle. The center of the circle is G. So in circle G, segment FG is 3. Segment GA is 5. And segment AH is 4. Find PJ and LA. And I'm assuming that L is way down here. So, well, what do we know? If these are perpendicular, then they are, well, we don't know that they're equidistant yet. What do we know about this? This is a right triangle. This is a 5, 4. What's that special right triangle? A 3, 4, 5. So if the hypotenuse is 4, the two legs have to be 3 and 4. Oh, look, these are the same distance. These are the same distance. That means that they're equidistant. So that means that all of the pieces that are like, if the segments are equidistant, then the chords are congruent. So if this is 4, this is 4. And if this is 4, this is 4, because these come from a radii. We know that because radii are perpendicular to the chords. So JP is 8. And LA is also 8. If I asked you, I don't know if you guys remember how to do this or not. You said something, Logan, that's been like in the back of my brain for the last 2 questions. So you brought this up. It's your fault. Okay. So think of this triangle right here as this piece right here. I know it doesn't look like it, but just pretend that they're the same. If I know this angle measure right here, I'm going to call it theta. Then I can figure out the measure of this arc from here to here. True or false? If I know this angle measure right here, which is a central angle, then I know this piece of my arc. Yes, I do. Okay. So really I could take that angle and multiply it by 2 and be able to figure out the whole arc. But the question is, how do I figure out what that angle is? Logan said it earlier. Do you remember? Say it. Yeah, the trig functions, what are they? Yeah, SOHCAHTOA. So if I'm looking for this angle right here, this is the side that's opposite. This is the hypotenuse, and this is the adjacent side. So I could say that the sine of theta, I would like you to squeeze it in there. The sine of theta equals the opposite over the hypotenuse. I could use that formula. Or I could say that the cosine of theta equals the adjacent over the hypotenuse. Or I could say that the tangent of theta equals the opposite over the adjacent. So we're going to do a little experiment to see if we can find out what that angle measure is. So I want everyone to pick up their calculators. If you are wearing tennis shoes today, you're going to do the sine of theta equation, okay? You're finding the angle measure, so you have to remember you have to use the arc sign. Do you guys remember that? If you're looking for the angle measure, you need to use the arc sign. So you're going to press the button that looks like this. So you have to use the second degree. So if you're wearing tennis shoes, you're doing the sine of theta. If you're wearing not tennis shoes, flip-flops, loafers, boots, Crocs, whatever, you're going to do the cosine of theta. And then Max and I are going to do the tangent of theta. So you still have to use the arc. So you have to hit the second function and whatever your degree is.
Would be the sine -1.
Mm-hmm. So tell me what we get. SOHCAHTOA. Some old hippie caught another hippie tripping on acid. How do you put it in your calculator? Second. And then press the tangent button. And then you do 4 divided by 3. Tripping on acid. That's how you teach. Yeah.
Oh yeah, that's the one thing I did learn in that class.
There you go. So I got 53.1 degrees. What did you get? Max, what did you get? Can I see what you did? Mode. You have to be in degrees.
I think your other classes need to change that.
Oh yeah, they're patooties. Okay. What did you guys get for the cosine angle measure? I mean, I can do it. If you're not going to shout it out. Cosine was what? 3 divided by 5?
Oh yeah.
That's 53.1 as well. If you're not getting 53.1, then you're not in degrees. You're not in degrees under the mode. You have to go to the mode and hit 50. You have to put it in degrees. So the sine, second sine, 4 divided by 5 is also 53.1. So if I wanted to find the arc measure here, I would just take that and multiply it by 2. 106.2 degrees. You might have a question like that. I want you to be prepared for it. All right, number 6. In circle A, FG equals 3x minus 4. So I'm going to write that 3x minus 4. And HJ equals 14. How could we set this up to solve it? Why? Why are they congruent to each other?
Because AL equals to MAP equals to.
Yeah, it's because they're equidistant. The distance from the center is the same, okay? All right, I just want you to know why you can do that. Add 4 to both sides, add 4 to both sides. 3x equals 18. X equals 6.